A function is defined as f of x is equal to 2x minus 3. Does anybody remember what this means? Whatever number I'm given, I'm going to do what to it? Whatever number I'm given, and then take away 3. What number am I given in the first one? 2. 2 times 2 minus 3? 4 minus 3, which equals 1. That was easy. What about the next one, f of 0? 2 times 0 minus 3? 0 minus 3? Minus 3. What about the third one, f of 3? 2 times? Minus 3. And that will get you? 3. Finally, the last one, f6. 2 times 3 minus, 2 times 6 minus 3. 12 minus 3 equals 9. You want to pick up full marks with that, right? Yeah? Full marks. Now, moving on. A function f is defined by f of x equals 5x minus 3. What's the rule, guys? What's the rule this time around? F of x equals 5 times the number, take away 3. Okay, what's the number in the first one? 2. What will 2 turn into? 2 will turn into 5 times 2 minus 3. Turns into 7. What does minus 1 turn into?
Minus 13.
Minus 1 turns into, let's find out, 5 times minus 1? Minus 3. Minus 5 minus 3? Minus 8. Pay attention. You replace in the number that you're given on the left and it turns to the number on the right. So A is 7 and B is minus 8. Right.
In a test, would we have to rewrite the diagram?
You could just do this. A equals 7, B equals minus 8.
So when you've finished all of them?
Yeah, you can just do that. Now the next one's an odd one, okay? The next one says that the input turns into an output of 12. So what this means is that whatever your input is, yes, Aaron.
No, I'm just gonna do it.
So we have a rule. 5 times the number minus 3 equals 12. What is that number? So the way Aaron might do it in his head was, well, if I get 12, the last thing I did was took away 3. So to reverse that process, I can add 3 to get 15. 5 times this number must be 15. So what is that number? 5 times what number is 15? 3. So you divide by 5 and you get 3. Now that's the way you do it in your head. That's the way you used to do them. This is the way you're going to do them now. 5 times your number minus 3 equals 12. Everybody agrees? Yeah. Bring the 3 over to the other side. That's adding on your... It's adding on your 3, isn't it? So you get 5x equals 15. And you're now at this stage here. And then divide 15 by 5. So you can actually see algebra is actually what you do in your brain, except you're explaining it. Kenny? So what you're asked to do is you're asked to draw a calculator. So you're asked to draw a calculator, you're asked to draw a graph. It starts at minus 4, ends at 3, and you're drawing this graph here. You go to your calculator, you press mode, you press table. Everybody got that? Then you come across, and what you read first? X squared. Where's the X button on the calculator? Red button.
So the bracket is.
Yeah, x squared plus alpha x, and then take away the 6. Has everybody got that far? Where do I start? Start at minus 4. You end at 3. And then your step 1. What points do we get? Has anybody got that list of points up yet? Huh? Mode 3. Table. Okay. What do we do next, guys? Write out all the points. Barry called them out to me.
-4, 6.
Yeah.
-3, 0.
Yeah.
-2, -4.
Yeah.
-6, -1, -6.
Thank you.
0, -6.
Yeah.
1, -4.
Yeah.
2, 0.
Yeah.
3, 6.
Yeah.
That's it.
Okay, guys. Some rules when you're drawing these. Rule number 1. You don't draw your graph like that. What did I do wrong?
Not on the line.
It's not on the line, it's little squares. Alright, give me another reason why this one's wrong.
Because you don't have it on the line.
Don't have it flush on the line, do I?
No.
That's not gonna work, okay? So you go flush on the two lines. And now, how high do I have to go up?
6.
And how low do I have to go down?
-4.
-6, okay? So let's go down in blocks of 2. -1. Will I fit it in? The bigger your graph, the more accurate it is. The smaller it is, the less accurate. I got down to -6 easy enough, didn't I?
Yeah.
1, 2, 3, 4, 5, 6. That's handy enough as well, isn't it? Now, the axis has to have the same gap. I'm saying 2 blocks is worth 1. That means 1 block is worth a half. Okay, you have a question, Ryan. Count across. What's it? -4, is it? -1, -2. Do you see the way I went in blocks of 3? Isn't going to affect you in your exam really, but you're allowed to have different. See the way I'm saying 3 is worth 1 on this axis? I'm allowed to do that. Okay. It only has the y-axis. Every 2 is worth 1, and on the x-axis, every 3 is worth 1. It's your choice what you want to do. Okay. It's making my graph more spread out as opposed to sharper. That's all the difference is. Okay. Now, what's the first point, guys? -4, 6. Anybody? -4, 6.
3, 6, and
Then -3, 0. After that, 2, -4. There. Yeah.
0, 6.
Yeah.
1, -4.
Yeah.
2, 0.
Yeah.
3, 6. 3, 6.
Okay, now guys, see the way the 2 of these are at the same height as each other? You're not allowed to do this. I repeat, you are not allowed to do this. Somebody tell me what's wrong with it.
Oh, there's no
curve.
curve.
It's not really a curve, is it?
You have to either do a curve.
Although the first part sort of seems alright though, doesn't it? So what you could do here is, you could, we're just going to take out these ones here. And maybe just that one there, that one there. Another question, is there? Right, Ryan?
When I put in the question into my calculator,
Yeah.
it automatically comes up what the start is. And then
Yeah. Sometimes that happens and then sometimes you have to change it. Now guys, I've sort of drawn it more or less. I've drawn it more or less myself now, okay? Everybody happy enough with that? What's the one problem I have there?
And you're saying the bottom of it is it's not curved.
You got to drop in between, halfway in between both of them, don't you? So, see this little bottom part here? You got to drop underneath and then come back up again. Does everybody see that? Underneath and back up again. Charlie,
what do you have to
what's the keywords here? Keywords in the question? Use your graph. Find the values of x for which f of x equals 0. That's the same thing as saying find the values of x for which y equals 0. When does y equal 0? Let me know. Is it equal to 0 here? What is it equal to here? 6. The y value is 6. What about here?
2,
Y value is 2. What about here?
0,
Y value is 0, so it's x equals.
0. Oh, sorry, minus
The y value is 0, but the x value is And then what happens when we go around again? The y value here is minus 4. It's minus 6. It's minus 6. It's minus 4.
2.
And now it's 0 again. So x equals
2.
2. Estimate the values of x for which the y value equals. You can see it, can't you? Minus 4 here and minus 4 here. So the two answers should be minus 2 and. But you got to use the graph, don't you? So you go down to minus 4 and you go left or right of minus 4. See minus 4? I'll put a dotted line here. You go up. So you go across and then you go up. And then you go across 1 second and then you go up. The two answers are what we expected them to be, aren't they? Minus 2 and 1. Okay, right. Estimate the values for which f of x equals 4. The y values equal 4. Go to 4 on this axis and what happens there? Hit and go down.
3 and no 2.
About 2.7 I'd say. X equals 2.7 and the other one? This one here? Minus 3.6 minus 3.7 somewhere. Now Ryan asked me for a reverse question, okay? I'll write out that reverse question now. The reverse question Ryan wants me to explain is, we'll call it part 4, IV. Use your graph to find what is the, let me see, we go for 2.5, yeah. What is the value of f of 2.5 and f of minus 3? Now, see that question I wrote down there, Ryan? What is in the position? See the way it's usually f of x? Would you agree with that? It's usually f of x.
Yeah.
Okay. What's in the x's position?
It's the actual number.
2.5. This means that x equals,
2.5.
and you're trying to find out what the
Y.
y value is. So go to 2.5, which is here, halfway between 2 and 3. Go up until you hit the graph, and then go across. So what do you think your answer should be?
3.
About 2.8? Yeah. And what about f of minus 3? F of minus 3, anybody?
That would be 4.
What?
4.
When x equals minus 3,
It's 0.
the y value is 0. So f of minus 3 is 0. That's the reverse question you're talking about. Charlie. Now, write down the radius of the semicircular end. So this is an athletics track. You're starting here and you want to do a full lap until you're all the way back where you started again. Everybody happy with that? Barry, describe the shape of the track to me. Straight line. After the straight line, semicircular end. After the semicircular end,
A straight line.
and then after the second straight line,
And then semicircle.
okay, another semicircular end. Okay, so that's how you travel across it. Now, what we're asked first is find the radius of the semicircular end. It says 98 meters from here to here. So what's the radius?
The radius is half,
Half of 98?
which is 47.
49. 49 meters.
Oh yeah,
49 meters, yeah. Okay, now, calculate the length of both semicircular ends. Can anybody tell me what angle is in here?
it's a 90. Oh no, 180.
180. Okay? There's a formula in your notes to get the length of the semicircular end. Can anybody find that formula? Yes. Theta, yeah, over 360. And it gets multiplied by what? 2. So it's the length of an arc. So it's theta over 360 multiplied by 2 pi r. What page did you find that on?
18.
18 on yours?
Yeah, I don't know.
Okay. So if you're looking at your tables in your tests, what you need to look out for, it's on page, you keep going backwards, and it's going to be on page 9. You see page 9? See where it says length? That's there, you should know where to find it. Page 9. Now, yes.
What do you, like, if you're doing this in, like, your calculator,
This 0 with a line through it, as it's called, refers to the angle you're looking at. It's called theta. It refers to the angle you're using. In this question, we're using an angle of 180. That's 180 over 360. Then you're going to multiply it by 2. What does it say pi is?
pi is 22 over 7.
And then our radius?
Is the power of 49.
49. Okay. Now we're going to enter this into the calculator. And also we have to show Charlie is what's in the calculator. Okay? Okay. 180 divided by 360. And then you're going to multiply what you get.
77.
Good man. 22 over 7. Then you're going to multiply by 49.
154.
It's okay, 154 meters. Okay. Equals 154 meters. So what does that mean about this? These semicircular ends? How much is each one of them worth?
154 meters.
154 meters each, and another 154 meters. Okay, what about the two straights?
You say 146 multiplied by
146 meters per straight, right? Now, can anybody else tell me another word for doing a lap? It begins with a P. The length of the track is the same thing as the perimeter of the track. So what's the perimeter of the track, guys? 146 plus 600 meters. Is that alright, 600 meters? Okay. So everybody's agreed 600 meters. Also known as the perimeter. Remember that word. Now, calculate the number of laps an athlete would have to complete in a 5.4 kilometre race. What is 5.4 kilometres in meters? 5,400 meters. Because 1 kilometre is worth 1,000. Kilo means 1,000. Divided by 600 meters per lap. Sorry? 9 laps. An athlete ran 4 laps in 10 minutes. Calculate the speed in kilometers per hour. This is another important question. Gonna see that again very soon. Anybody remember the DST triangle? So first of all, how much is 4 laps worth? 4 multiplied by 600. Anybody? 4 multiplied by 600. 2,400 meters. Change that to kilometers. 2.4 kilometers. An athlete ran 10 minutes. Yeah? 10 minutes, okay? Just give me a second. 10 minutes is how much of a hour? 10 divided by 60? 1/6. So you have 2, and does anybody remember the distance speed time triangle?
Distance,
DST. Which one are you looking for?
the time. Oh, it's like the distance over time. What?
You're looking for the speed. You're right though. Colour out S, and what's left?
Distance and time, yeah. Okay.
So 2.4 divided by 1/6. Okay, 2.4 divided by 1/6, which is 14.4 kilometers per hour. Ryan? Yeah.
Could you not just times it by 6? Not the exact same.
If you times it by 6, you have to times the amount of distance you covered by 6 as well. So you're right, you'd get a same answer. I'll show you another way down it. You can do your 2.4. Remember we were talking about the calculator the other day and how it does minutes, yeah? What's 2.4, yeah? Look at this. 2.4 divided by 0 hours, 10 minutes, right? Press the change button. 14.4 kilometers an hour. It's another way of doing it.
And
Aaron.
how does it take 2.4